Welcome to This Explainer. Today, we're completely stripping away the mysticism of the sleeping mind to explore the hard, cinematic neuroscience of lucid dreaming. For a long time, the idea of waking up inside your own dreams, well, it was basically relegated to the fringes of science. People thought it was just a myth or some purely esoteric practice. But modern neuroimaging and EEG technology, they've completely changed the game. So today we're going to look at the exact biological mechanisms that allow us to become fully self-aware and even gain intentional control while our bodies remain totally paralyzed in deep sleep.
So let's dive right in by asking ourselves a really profound question. What actually happens biologically when the boundary between waking reality and the dream world collapses? Normally, when you go to sleep, your executive functions basically power down. You lose your sense of self-directed agency. Bizarre things happen in your dreams, and you just accept them as reality, right? Because your critical faculties are offline. But in a lucid state, something extraordinary happens. A biological switch flips. The conscious mind boots back up and literally hijacks an environment that was entirely constructed by the subconscious.
To get really precise, what we're talking about here is a highly specific hybrid state of consciousness. In this state, you are objectively asleep, meaning your physical body is showing all the clinical signs of rapid eye movement or REM sleep. Yet, subjectively, you're self-aware. This isn't just having a really vivid dream. No, this is a state where you have active metacognitive monitoring. You can actually think to yourself, wait, I am in a dream right now. And from there, you can often exert total control over the dream's narrative, your environment, and your own actions. Here is our roadmap for today's explainer. We'll start with a hybrid conscious state, then unpack the neuroscience of lucidity, look at evidence-based dream induction, explore healing trauma through dreams, and finally, discuss the risks of dream control. All right, let's jump into part 1, the hybrid conscious state. Let's look at the baseline first. Normally, the frontal parts of your brain experience strongly attenuated activation and very low gamma synchronicity during REM sleep. That's exactly why you lack conscious awareness. But in lucid REM sleep, we see this massive explosive spike in 40 Hz gamma power, specifically over the frontal electrodes. Now, this 40 Hz frequency, that is the neurological signature of conscious awareness. So your arousal system is essentially being pushed toward waking, yet the brain remains locked within the physical paralysis of REM sleep architecture. It's a fascinating but highly destabilized hybrid state. Moving on to part 2, the neuroscience of lucidity. So, what's happening under the hood? While normally dormant during sleep, these specific brain regions suddenly fire up to form a synchronized frontoparietal network. This is what gives you spatial and metacognitive control. The dorsolateral prefrontal cortex, or DLPFC, comes back online to provide logical evaluation. It's what lets you realize, hey, breathing underwater is physically impossible, so I must be dreaming. Then the anterior prefrontal cortex kicks in to provide self-reflection. Actually, MRI scans show that frequent lucid dreamers often have a larger gray matter volume in this exact area. Finally, the temporal parietal junction helps you navigate your dream body through this hallucinatory space. Together, they create this incredible feedback loop of awareness, completely decoupled from the external world. Now, this is where the nervous system regulation gets really interesting. This lucid state is an incredibly delicate neurochemical balancing act. On one hand, you have cholinergic transmission, acetylcholine, from the brainstem, which is absolutely crucial for keeping you in REM sleep. But on the other hand, to gain executive control, access your working memory, and actually do things in the dream, your brain has to recruit dopaminergic transmission. If this dopamine-acetylcholine balance tilts too far, boom, you just wake up. But if it drops too low, you slip right back into a normal, oblivious dream. Which brings us to part 3, evidence-based dream induction. Because spontaneous lucid dreaming is incredibly rare, scientists rely on specific induction techniques to study it. Step 1 is the wake back to bed method. You sleep for about 5 hours, wake up briefly, and then return to sleep. This isn't random. It perfectly aligns with your circadian biology, intentionally targeting the longest, most dense REM periods that happen in the early morning. Step 2 involves the mild technique. This is where you set a firm perspective memory intention. You basically repeat to yourself, next time I'm dreaming, I will remember I'm dreaming. It essentially trains your brain to recognize weird anomalies as dream signs. Researchers have even tried applying transcranial alternating current stimulation directly to the frontal cortex during REM sleep, trying to artificially force those 40 Hz gamma waves. Sounds like sci-fi, right? Well, objectively verified lucid dreams only occurred in a really small fraction of the trials. It turns out, simply zapping the brain with electricity isn't a magic bullet for self-awareness. The brain's architecture is remarkably resistant to objective induction alone. But check this out. 57%. That number is absolutely staggering. It represents the success rate of achieving a lucid dream when cognitive training is paired with pharmacological intervention. In clinical trials, when participants combined their cognitive induction techniques with a specific off-label medication, a massive 57% of them successfully had a lucid dream on at least 1 out of 2 nights. Right now, this is the single most robust, evidence-based approach to triggering the lucid state. So what is this breakthrough? It's galantamine. This is a well-tolerated drug that temporarily inhibits the breakdown of acetylcholine, which dramatically increases your waking memory function right inside the dream. It was originally used to treat memory decline and Alzheimer's disease because it acts as a fast-acting acetylcholinesterase inhibitor. Basically, by stopping the enzyme that naturally breaks down acetylcholine, this neurotransmitter pools up in the synaptic clefts of the brainstem. If you take it right at that 5-hour wake-back-to-bed mark, it skyrockets your REM density and bridges your waking memory directly into the dream state. In one double-blind trial, an 8-milligram dose resulted in a 42% increase in the ability to lucid dream compared to baseline. Pretty wild, right? Okay, let's look at part 4, healing trauma through dreams. As neuroscientist Dr. Martin Dressler points out, reconnecting the prefrontal cortex allows a dreamer to recognize contradictions and maintain their core identity, even when they're facing severe psychological distress. By bringing that self-awareness online, you don't just passively endure your mind's hallucinations, you can critically evaluate them. And this is exactly why lucid dreaming is moving out of the sleep lab and directly into the therapist's office. Think about trauma patients. Gaining cognitive reappraisal inside a nightmare allows them to literally rewrite the story in real time, like turning a terrifying pursuer into a harmless guide. This is known as lucid dreaming therapy, or LDT. For folks suffering from PTSD and chronic nightmares, sleep is often a space of intense vulnerability and terror. But if they can achieve lucidity, they engage in what psychologists call resignification. Because they know the dream isn't physically real, it acts as a zero-stakes environment for exposure therapy. It allows them to actively regulate their autonomic nervous system in real time. They can confront their trauma, reframe the threat, and experience a profound sense of mastery over their own emotional processing. But we have to look at the flip side. Part 5, the risks of dream control. You see, normal, non-lucid REM sleep plays a vital role in our biological recovery and emotional regulation, precisely because the prefrontal cortex is offline. When you force executive control into that space, you disrupt that passive emotional processing. Plus, constantly overriding your sleep architecture with these induction techniques can severely fragment your sleep. It can disrupt the deep, slow-wave sleep that your immune system and your cellular recovery absolutely rely on. And if you are constantly forcing your brain into this highly energized, high dopamine hybrid state, you're actually triggering an artificial stress response. Over time, disrupting your serotonin regulation and constantly overactivating your HPA axis, which causes elevated cortisol, can actually lead to the very anxiety or depressive symptoms that some people try to cure with lucid dreaming. For psychologically vulnerable individuals, it also increases the risk of sleep paralysis and dissociative states. It's a serious biological trade-off, which leaves us with a really profound dilemma to consider. Just because we have the neurological tools to conquer our subconscious, does it mean we always should? Lucid dreaming offers an unprecedented window into consciousness. It proves we can actively navigate our own neurobiology, and it clearly holds life-changing therapeutic potential for those battling chronic trauma. Yet, as we've explored today, it also demands a disruption of the brain's delicate, highly evolved mechanisms for rest, nervous system regulation, and emotional digestion. The science shows us exactly how to wake up inside our dreams. The real question now is figuring out exactly when we should just let ourselves sleep. Thank you so much for joining me on this explainer, and as always, keep questioning the science of the mind.